Yes, good morning, students. So today it will be static, limiting, and kinetic frictional force that we'll be studying, and very interesting concept. And I already have told you, my voice is audible to you all. Good morning. Okay, so for static, limiting, and kinetic frictional force, to understand it, I'll be giving you the same theory that I have told you earlier. That when you try to push an object which is very heavy, so to apply force, and it is to be one object that can be movable. So when you start to apply force over that object, and you initiate with a small amount of force, you see that the object is not moving. You increase the force, and you still see that it's not moving up to a certain point. When you apply certain amount of force which makes it move just to the edge, and then when it starts moving, then you need not to apply the same amount of force. Lesser amount of force is applied, is required to make it move. So we will be explaining these three phases: static, limiting, and kinetic frictional force, with the same example and on a graph paper. Along x say distance, and along y say we are taking force. The force increases, the force applied, sorry, along x-axis, let's say force applied, and along y-axis, the frictional force. The frictional force increases as we apply the force up to a certain point, and the object doesn't move. This amount of force is known as static frictional force. Let us say this is point O, and the peak point says A. But when the object is at the verge of moving, a small amount of force also increases. Maximum, let's say maximum static frictional force, this point is known as limiting frictional force. I'll name this point to be B. OA is static frictional force. Static means at rest. When the object is at rest and the frictional force is being applied, then it is known as static frictional force. And when it is at the verge of moving, okay, when it is at the verge of moving, I'll not say that uh, OB, because it will be in OA. Let's understand this thing. OA is varying, means it is having different values. This different values are there. This is all static frictional force. But limiting frictional force is having a single value, the single value. Okay, OA is varying, but OB doesn't vary. It is a single value. OB is known as limiting frictional force. Why it is called limiting frictional force? Because this is the limit of the force, the maximum limit. Now, why I'm saying maximum limit of the frictional force? Because either it is static or it is kinetic. The limiting frictional force is maximum. Now comes the third part. The object has started moving from B to C, say. Let's name this, rather than OB, let's name this AB. From O to A, it's varying static frictional force. AB is limiting frictional force. Okay, what's limiting frictional force? The frictional force applied when the object is at the verge of motion. Means it is about to move. At that time, the amount of frictional force applied by the two surfaces is known as limiting frictional force. Now comes BC, is kinetic frictional force. Obviously, what is kinetic frictional force? When the object starts to move, motion. When the object gets into motion, it has the kinetic frictional force from B to C, and you can clearly see that this value is less than the kinetic frictional force is less than the limiting frictional force. So what it generally means that you start applying force over an object to make it move. You increase the force. I'll show in the diagram alongside what I am telling you. You will observe it. You increase the force gradually, and the object still doesn't move, and a point comes when the object is at the verge of motion, and as soon as it starts moving, you suddenly feel that less amount of force is required to make it move, to continue this motion. So this is how you understand static frictional force, limiting frictional force, and kinetic frictional force. So you do tell me whether you understand this concept or there is any problem. I'll repeat it for you. Otherwise, we'll move forward. Still waiting. If you have got any problem, Do tell me, otherwise we'll move forward. So let us see now how this on what factors does this frictional force depends. Till now we have discussed two things only. Suppose an object is lying on a horizontal surface and we are trying to push it in a certain direction by applying some force. The object is not yet moving, so it means that equal amount of force is being applied from the opposite direction. And if the object is not moving, let's say frictional force small f is being applied from the opposite direction. Other than these two forces, there is one more force being applied over the object, different pair of force, because if this object is not moving sideways, this object is not moving upward or downward. So that means the weight mg is being balanced by another force, and that force is known as normal reaction force. You can name it by N or R. It's up to your choice. In different books, different notation has been given. Let's say R we are taking for normal reaction force. Now this frictional force, it depends upon R, normal reaction force, which is the counterbalance of the weight force mg if this object is lying horizontal on a surface. So this frictional force depends upon R, or ultimately it depends upon mass or weight of the object. It means that if the weight of the object is greater, it is hard to move. The one which is light obviously is less hard to move. Less amount of force is required to make it move, you can say. So this frictional force, it is directly proportional to R, normal reaction force. And the second thing it depends upon is the amount of contact between two surfaces. So that amount of contact is given by the proportionality constant mu. This is called coefficient of frictional force. Now it's different for different category of frictional force. We are having three: static, limiting, and kinetic. For static, the value varies if the object is at rest, then this frictional force has to be less than or equal to this mu into r. The object is at rest. I'll name this mu s static, or coefficient will also become coefficient of static friction. This will become coefficient of static friction. R will remain same. This, there are two terms, mu s into R. This is the case where the frictional force becomes limiting frictional force. This is the case for limiting frictional force. Now the last one comes for the kinetic. The coefficient becomes k, mu k into R. This is kinetic frictional force. So it depends upon whether the object is at rest or in motion. These three equations will vary according to that. Now you'll have to tell me, and the is 0.4 the unit of coefficient of friction, because coefficient of friction is the ratio of forces, and if it is a ratio of forces, then it has no unit. If an object weighs 9.8 kg Newton and the coefficient of friction between the surfaces is 0.4, then how much of force about to move? Answer this question. This is very easy one. I'm still not getting the answers. So I'll explain this. This value, let's say this is mu s, static frictional force 0.4, and you have been given mu k to be 0.2. Now, as you can clearly see, the static frictional force is not a single value, rather it's a range of values depending upon the value of mu s. Here what we have considered is the maximum value of mu s. So Fs is going to be less than or equal to mu s, that is 0.4, into the normal reaction force, that's equal to weight. The body is lying horizontal, 9.8, and this Fs will be less than or equal to 9.8 divided by 4, or 4 by 10. It will become 3.92. And when we'll be discussing about Fk, it will be a single value. It will come out to be equal to 0.2 multiplied by 9.8, 1.96. Now the frictional force when the object is moving and when the object hasn't started moving is different. Now this value of Fs, if we consider this value is ranging from 0 to 3.92 depending upon how much force we have applied. The interaction between the surfaces remains same, but when the object starts moving, the interaction between the molecule